that note, I will hand you to our next speaker, which is Princeton Satellites.
Hello everyone, I'm very happy to be here. I'm Layla Mohsen and I work at Princeton Satellite Systems. And today I present to you a vision for sending humans to Mars by the works of Princeton Satellite Systems. With over 40 years of experience in the space industry, Princeton Satellite Systems and its engineers have contributed to major space missions, including the GPS-2R, the Space Shuttle Orbiter, and Endostar-1. And today, their software is used by leading space organizations all around the world. Building on that experience, its engineers have proposed a mission architecture that could change the way we view deep space. At the heart of this architecture is Starfire. Starfire is a fusion reactor that uses deuterium and helium-3 for its fuel. Now, fusion, as many of you may know, is the process that powers the sun, and it releases a significantly larger amount of energy than chemical propulsion systems per unit of fuel. This means faster travel and lower mass. And as opposed to the common fusion reactors that use deuterium and tritium, using deuterium and helium-3 releases significantly lower harmful radiation from neutrons, with around 1,000 times lower neutron power flux. This makes Starfire a cleaner and safer option for space missions and for future use here on Earth. The Starfire architecture is based on the Princeton Field Reverse Configuration, which is currently under experimentation in the Princeton Plasma Physics Lab. For the human Mars mission, there are 4 main elements. You have the Mars base, the landers, and the ascent vehicle and transports. There are 2 main transports, one for the crew and one for the cargo, both of which are powered by Starfire. The cargo transport launches first, and it follows a slower trajectory to conserve fuel. It takes around 2 years to reach Mars, and it carries everything that the astronauts will need, including the Mars base, the supplies, and the ascent vehicle. This really lowers the load on the crew transport, which can allow the astronauts to reach Mars at a faster time. The crew transport takes place 1 year after the cargo transport reaches Mars, and it arrives Mars in 64 days only, and this is made capable by the Starfire. Now, the reason why the short transit time is very important is because the less time that the astronauts spend in space, the less they are exposed to cosmic radiation and microgravity, which can impose serious health risks. When landing on Mars, the lander follows a 3-step sequence that is inspired by the NASA Viking mission. First, the aeroshell slows down the spacecraft on its entry to the Martian atmosphere. Then the parachute deploys to further slow down the spacecraft, and then the thrusters are ignited to guide the spacecraft to a soft landing. The thrusters use a dual-mode propulsion system that uses nitrogen tetroxide and hydrazine for its main fuel. Once landed on Mars, the Mars base is built using robotic construction vehicles. It takes from 6 months to 1 year to be complete. It is built underground to protect the astronauts from external radiation, and it is powered by a 1 megawatt Starfire reactor. It also includes a garden that provides fresh fruit and vegetables to the astronauts for their stay. Now, for departure, the crew takes the ascent vehicle, which is powered by an RL-10 engine that uses liquid hydrogen and oxygen for its fuel. This fuel can actually be made on Mars by the electrolysis of its water. The high electrolysis power would be powered by the Starfire reactor. It would take around 10 days to complete the fuel. Both the crew and the cargo use the same lander and the same air shell, and these are their respective transports. The current work in progress for Princeton Satellite Systems is that they are focused on developing the test reactor Starfire 1 and on refining the mission elements. All of the simulations and the calculations that are discussed in this talk was made using the PSS Space Control Toolbox. It is a complex effort that is driven by a talented team of engineers and scientists. Thank you so much. I introduce Sven Sharp to the stage.
Hello everyone, my name is Shui.